My name is Cochran. I'm the COO and co-founder of Oklo, Inc. Oklo is a company using advanced fission to make clean power plants. What is fission, you might ask? Fission is the reaction in the atom where a neutron splits the atom and creates a lot of energy. Advanced fission is a way we can use that same fission reaction like is used in nuclear power plants, traditional nuclear power plants, and actually use it in a way that we can make small power plants that have inherent safety characteristics and can even use nuclear waste as fuel. So let me first say I'm just really excited to be here. The energy here is amazing, and each one of you, and I suspect, as well as such a large group of people, are thinking about so many different solutions for the things that plague our world and for improving our futures. And so I'm really excited to be here. I'll say, as I was going on my own journey, thinking about where I want to invest my life and improve our futures, I was in undergraduate school, I was learning about energy, I was a mechanical engineer, and I was really excited about being a part of thinking about where I was going to put my life next. I learned about nuclear power in that time period, and like many of you, I was thinking, is that really safe? Is that really useful? Isn't that old? And I learned it's actually quite safe, and it can produce incredible amounts of energy for any unit of input that you have. So I was really excited about that potential. I learned more about it, and I actually decided to work for a year in startups and then apply to graduate school where I got into MIT for nuclear engineering. And I was so interested in that fact, but actually while I was at MIT, I learned my co-founder was there, and he taught me more about how you can actually even use advanced fission to utilize waste as fuel and convert it into clean energy. And it was in those times that we started kicking around the ideas that became our company. And I also learned about how nuclear energy has actually had the capacity to decarbonize whole countries. So France was able to largely and deeply decarbonize using nuclear energy in the past. At the same time, we don't have to do it the same way it's been done before. So that's how really our company began. One of the metrics, if you can boil it down to one metric, is life cycle carbon footprint. And the Intergovernmental Panel on Climate Change, IPCC, has done recurring assessments of the life cycle carbon footprint of different energy types. And here on this graph, you can actually see several different types and how they compare. And this is a log chart, so hopefully you're familiar with that, but it actually means each line is an order of magnitude larger. So the differences grow exponentially. You can see all the fossil fuels, biomass, et cetera. The life cycle carbon footprint is quite high, right? But this allows us, the log chart allows us to see down into the other energy types like renewables and fission. And even between those, there's some differences here that are helpful to be able to see, but you can see all of them are kind of on that lower end. And when I think about the future of energy, as we're discussing here at this conference, it really has to be about getting down to the lowest life cycle carbon footprint, right? To produce energy which humankind needs and wants, but do it in the least impactful way and the way that saves the most time and space and resources for nature as possible. So that is another thing that just gets me out of bed every morning, but also drew me to doing this in the first place. Another way this can be illustrated is actually a golf ball. So your entire lifespan's worth of fuel to power your life using nuclear fuel would be in the size of a golf ball. So that illustrates the kind of energy density we're talking about here. Fundamentally, the physics of it is that a single fission reaction produces millions of times more energy than a single combustion reaction. So combustion being used in biomass, biofuels, fossil fuels, et cetera. So when you have that incredible energy density, there's so much more you can do with something, ultimately making it hopefully not only more lower life cycle carbon footprint, but hopefully also less expensive as well. And to illustrate the expense and the materials needed for any different energy type, so we've talked about life cycle carbon footprint, the amount of materials. Here you can see, and it kind of keeps zooming in because you wouldn't even see it if we try to put it on a chart. Fossil fuels, the amount of fuel needed per energy output is huge, right? And then we have to zoom in, and you can see how basically some renewables and fission compare. And even below that is fission in terms of the amount of materials you need to make energy. One of the neat things about what we're working on is not only that, but actually recycling that small amount of fuel and recycling it over and over. And so that's actually the next thing I'll be talking about. But also, when we have lowest amount of materials, obviously here we're talking about climate change and emissions and how do we reduce impact on the Earth. But I think the only way we're really going to get there quickly is if it also makes sense economically. Generally speaking, when humankind gets to these choices of like, well, will I do this thing if it's significantly more expensive, even if it's the right choice, and if you can make the right choice, also the least expensive choice, which is our vision, then it makes the change happen not only faster, but be not a single question really for people when they're thinking about how they want to have their communities be powered, have their businesses be powered, and so forth. So business model is a huge part of that, right? Lowering the costs. If you have the least amount of materials, you also have, hopefully, the least amount of cost. But when we think about the future of energy and how far into the future can we power ourselves sustainably, often I get the question, what about fusion? Well, isn't that actually the fuel of the future? And as soon as that comes along, you'll be obsolete. And maybe this is a little bit of a playful jab. I think there's room for everything. Energy is by far the biggest market in the world. We need all the solutions we can get. But one of the things that's potentially quite interesting to see is this chart here. We can power the world off of nuclear waste existing in the world for over 100 years. So that's what you see in the first bar, is actually over 100 years, just existing waste on the planet, we could power the entire planet for over 100 years. So it's not even that much. You might think, oh, well, it must be a lot of waste then if we can power it. There's just traditional nuclear power plants use only about 5% of the energy and the fuel. And power plants like the ones we're looking at using, which utilizes what's called fast fission, can actually fission the remainder of the energy in that waste. So that is where that energy is coming from. It's actually a small amount of material. We know where every basically atom of it is in the world, but it can power the world. But then you think about the rest of what our stardust gives us here on this planet. Mined resources and everything else as we look forward in the future. What can we do with fusion based on earthly resources, et cetera? And so you can see actually using all of these resources on the planet, using emission-free power, we can provide power for actually longer than we expect the sun to be around. So that's an interesting thing when we're thinking about the incredible power resources we not only need now, but in decades in the future, hundreds of years in the future, and many visionaries and futurists are thinking about what do humankind look like? What does our economy look like? What does our energy look like? Maybe even thousands and millions of years into the future. And so it's a really fascinating thing, but it's also an important thing to recognize is that there's a lot of energy wrapped up in the atom here on this planet that we can allow us to spare the planet as much as possible. So it's hopefully an exciting thing to leave you with as we think forward. And thank you again for having me. I think Stephanie's coming out. She was going to ask more questions, I believe.
Apologies for leaving you for one second.
Worries.
I dropped my papers.
I went early.
I carry paper because there's no risk of running out of power or of being hacked. There's a risk of dropping it on the floor. So apologies for that. That was an absolutely fascinating presentation, and it had me thinking about what you and I were talking about before you came on stage, which is the energy needs of generative AI. So one of the big secrets of generative AI is how much more energy intensive it is than ordinary search, for instance. So if you've got every business and potentially even governments thinking, shit, we have to integrate large language models into our operations because we don't want to be left behind, their energy bills are going to go up. And their water bill is going to go up as well, because it takes more water to cool the entire system, but also the data centers. So my question for you is, if we are truly to use generative AI in a good and constructive way, but be kind to the planet and be energy efficient, do we need to be also thinking about a new energy source? And is this an option?
Yeah.
What are your thoughts?
It's a great question. And with all the discussion of AI, of course, the chair of our board is Sam Altman. He's been deeply involved in AI. And the way he sees it and the way we see it too is that abundant energy is abundant intelligence. They're intricately entwined. And so
what does that mean, though?
Yeah,
that sounds like a very Sam Altman phrase that I don't know what it means.
Yes, yeah, you need a ton of energy, just like you were saying. So when we talk to data center providers who are making huge commitments in terms of decarbonizing, they're, especially around the world, but maybe the closest example I have is in the United States, they are looking for those energy supplies and not finding them, to the point that they may have all their plans drawn up for a data center. They know they need to expand because of the needs of AI. In fact, they need to build whole new data centers because the type of compute needed is, as you know, a much more intensive type, requiring different types of servers, et cetera. They are being told by utilities in those areas, you can't build here unless you bring your own power. So it's an existential threat for data centers in general, but AI's expanse in the broader sense, to have power generally located near where the data centers are. So when we've looked at that, we have small power plants that can run 24/7, which is important. I think a lot of these data center providers have been parts of building up solar plants, trying to buy renewable energy credits, et cetera. But when they think about truly decarbonizing the electricity going to their data center that has to be up 24/7, they need a clean energy source that can do that literally 24/7. There's really not much other than nuclear that can provide that.
So is that an advantage for a country like France that has a nuclear fleet compared to, say, the UK?
I think that it is an advantage in terms of their power is very clean and it's very reliable. And you don't need to refuel it except once every few years for traditional power plants. For our power plant, it's once every 10 years. So the time that you need to have downtime is very low, which is, that reliability is essential for data centers. But is any one country ahead? I don't think so too much, because what we need to do is build more. And so that could happen anywhere.
So that this could herald a boom.
Yeah.
So if you're in the energy providing business, this is your time.
It's a very exciting time. It's a daunting time. It's an exciting time.
Do you feel, though, that companies are being transparent enough about their energy and water requirements? Like, is that going to be something where we could see, if you're looking at the regulatory landscape, and where we might see the European Union or, God forbid, even the United States get its act together and actually start to say, because we're trying to have a climate commitment, we're looking at sustainable energy, we're going to be requiring companies to report on their energy use, their water use, and their sources thereof. So maybe you don't locate in a hot place like Arizona for your data center. Maybe you're going up towards the Great Lakes. Or here in the UK, are you going up north? As temperatures are getting hotter in the south.
To reduce energy requirements. We are working with some in the south, in Arizona, in different places. But if you have abundant energy, you can even produce water out of the air. You can do all these kinds of things when you have abundant energy. So what I mean by that is, if your energy supply is energy dense, it doesn't need refueling once every 10 years. If the cost is low enough, you can do things like that actually minimize impact on the environment while enabling you to deploy data centers in the least impactful or least socially or environmentally important areas. So we are seeing that. In terms of the requirements on companies, I think we're seeing some of the biggest companies in the world make these commitments, maybe in anticipation of requirements, but maybe just because they see their own consumers caring about that a lot. So that's what's driving, for instance, for us, a lot of customers coming to us saying, we want our data centers decarbonized. And I've literally heard them say, well, we actually have customers that they don't just want to hear that we're buying renewable energy credits. They actually want to know the energy coming into our facility, what is the actual carbon footprint of that? I think some of that's being driven, at least in the United States, which I'm most familiar with. The SEC is requiring more carbon accounting now, so that was a recent change. But I think there's also just our customers, their customers are demanding that of them. And so we're seeing some of the biggest companies in the world, Microsoft, Amazon, Apple, you name it, Google, Facebook, wanting to commit to these things, and sometimes very aggressively.
Do you think that that will lead to them committing to greater transparency about what it's requiring for them to run these large language models, though? Because so far they haven't been.
I don't know what their plans are for transparency, but it seems like what best people like us can do is, as consumers, make sure that they know that we want to see where their energy is coming from. So that's something.
That's all of you. Get on your social media, start going. What about things that are standing in your way? What's blocking you from realizing your vision at the moment, and how could people help you? And who would you need help from to get it going?
Yeah, there's a long regulatory path. I'd say that's, in general, reasonable, right? Like there's certain industries that are regulated, and it makes sense. So we started that years ago. A lot of people think that the regulator is kind of what keeps it from happening. It is a burden and it's a challenge because the regulators are generally set up to regulate these big old plants. So just to put it simply, they're used to seeing gigawatt-sized water-cooled reactors that require whole rivers to keep them cool. And if they don't stay cool, then they're very unsafe, like Fukushima-type issues. We don't require water to stay safe. In fact, we don't really require any safety systems. We're not even water-cooled. We're very small. We're more like 15 megawatts than a gigawatt. So almost an order of 100 magnitude smaller. And so all these things show that there's inherent safety possible. But the regulators around the world, and in the United States too, are figuring out how to understand that so that they can regulate it in a different and better way, or even just regulate it at all, because their old style of application, you might say, is set up in a format to review what they're used to seeing. So that's been a challenge that we've been facing, but it's also one that we're kind of seeing the light at the end of the tunnel for. And so that's probably one of the biggest challenges. Outside of that, supply chain is a big one. And we're kind of growing. As our customers grow, it helps us to build out that supply chain. So
how is supply chain a challenge? Can you expand on that?
Yeah, mainly fuel. Nuclear fuel is not something you can just pick up at Walmart, and there's only so many suppliers in the planet, actually. And believe it or not, Russia was one of the main ones. So with Russia's invasion and so forth, that's obviously something we all want to get away from. It's also part of why our companies focus on using recycled waste as our fuel, so that we don't have to try to buy from different places. We wouldn't buy from Russia, no one really is at this point, but it's a reduced supply chain so that what supplies there are more expensive.
Who are your other people that you could buy from besides Russia?
So there's different steps in the fuel supply chain, but broadly speaking, France is one of them. United States is one of them. There's uranium that comes from Australia, all over the place. So there's a number of places to get raw materials, and then you enrich it, and then you supply it. But all of that we can kind of circumvent by using recycled waste material, which is our focus. So we're working on building up those facilities to have that fuel in time.
And how are you feeling about the talent piece? We focused a lot on that today, about the kind of people that you're looking to hire, that you work with, the sort of training that you feel maybe new graduates, younger students, or even people looking to pivot mid-career to get in on this.
Yeah.
What are you looking for? What would you advise people who find this space fascinating?
Absolutely. A lot of times we have people coming to us from all different spaces and just saying, I want to be a part of something that I see as a solution, and that's, I think, what drives most people who apply to our company. And they're like, but I don't know anything about nuclear power. And it's like, you really don't need to. We need everybody else just like every other company, right? We need business people. We need people who work on strategy. We need people who know how to write. We need people who know how to edit writing, because we write a lot of reports for the regulators. We need mechanical engineers, electrical engineers, you name it. So actually there's finance people. so
it's like any other company. There's nothing that's specific, but there must be some things that you're like,
yes,
this is the stuff that's hard to find, hard to source. So what about that hard piece?
That's a great question. So when I think about why it's so hard to find the right people, it's I think you have to have a passion for doing something that hasn't been done before. There's really no roadmap, and for some people that's exciting, for some people that's frustrating. Literally things, contracts that we're writing, reports that we're writing, everything we're doing hasn't been done before. And for some people that's exciting, and some people that is frustrating. And there's no book to turn to do what hasn't been done before. So I think people who come to us and are successful are passionate, they're smart and they're humble. And I think usually people come to us, they're already passionate about doing something in this space. Obviously, smart people help us to get the work done. And then, it's really important in our company culture to have low ego because, hey, it's never been done before. Let's try new ideas. It's really important to innovation to have that kind of camaraderie and low ego kind of atmosphere where it's not like, oh, it has to be done this way, because literally we're all figuring it out together.
I want to turn to all of you. We've got some mics that are here, so if anyone is feeling like they're ready to ask questions and go for it, the floor is yours. I will stand here just to hang out.
Thank you.
Hi. Thank you very much for the talk. I think it was quite insightful. I was very curious when you touched upon using the waste from traditional fission and then using that waste afterwards.
Yeah.
I think three kind of things that I'm curious about is, one is actually how is it done, and then what kind of yield do you get from that? Because obviously uranium has a lot more fission potential energy than its subsequent parts. So if you could go into that, and then also kind of give the efficiency of how much we get back from putting into those waste materials.
Yeah. It's an important paradigm thing, and this might be part of what you've heard before, is if you recycle nuclear waste, you can do it, and France does it right now, using these kind of big old plants. So they're called large light water reactors. So they're water-cooled and water-moderated, which means water is slowing down the neutrons to get into this nice energy range, because the speed is the energy, right, kinetic energy, and get in this nice energy range where it's perfect to fission the right isotope of uranium that we're fueling those plants with. So you can recycle those back into those light water plants, but they can only kind of eke out a few more percent kind of a thing. If you use that waste material, though, with all its impurities in a fast reactor, which means it's fast, we don't slow down the neutrons with the water. So it's not water moderated. In fact, it's not moderated at all. The neutrons are flying around really fast, and because they have that high kinetic energy, they can actually fission a greater range of the isotopes that are in that waste material. The amount more that you can get out of that, it really depends on how many additional cycles you do, but people talk about using fast reactors to actually fully close the fuel cycle. So you can keep doing that. In fact, there's interesting other things that you can do with it, and some of you might have heard of Bill Gates put a lot of money into a company called TerraPower to do something called a traveling wave reactor, which is fascinating because the idea is it actually breeds its own fuel in kind of a wave. So there's all kinds of things you can do there, but essentially the potential is limitless to not only consume the waste, but produce more fuel if needed. So getting down to basically eking out more than 95% of the energy in the fuel is possible with subsequent recycle cycles. So we look at doing, the fuel is worth it, is valuable to us for many decades into the future. We have it a decade, we refuel, we can keep recycling and keep doing that for many decades in the future. We look at, generally speaking, 80-year use cycle, which is fun for the finance people, but anyway.
We've got time for one really quick question.
Hi, thank you for the talk. I'm a recent architecture graduate, and I was wondering, you mentioned the compact size, not needing the water moderation. Could you see in the near future us having reactors, fast fission reactors, closer to urban centres? And then with words like unmoderated and fast reaction, how do you get that market perception? How do you get the populace to agree with living next to these reactors?
Yeah. Well, one of the things that already happens now is small reactors are already near different urban centers. So when I went to MIT, there was literally a reactor right next to my office, right? Right in the middle of Cambridge, Massachusetts. And so that does happen. Maybe people aren't aware, but you're right. How do people get excited about having this in their community? And we thought there's several ways to kind of make that possible, although it's not something we're shooting to do right off the bat. I think it ends up happening almost immediately due to the business offering that we have. So we're not selling reactors to cities that then have to spend money to build, own, and operate them. No, we build, own, and operate it ourselves. They just buy the power. So they tell us where they want us to be. And so it's unlike the traditional business model where there's big power plant, some big utility says, oh, we're going to plop it right here. And then everyone in that community is like, well, we don't want that right there. Instead, it's an opt-in model where consumers are like, we want this in our community and so forth. We have worked with architectures, studios, Gensler, you might be familiar, to design our power plant building. It's a concept. We don't have to use that, but it's been in Architectural Digest. I do think the appeal of the building itself and pointing to it and saying, hey, this is our clean power plant in our community, and being proud of that building and having it as a community center is something we focused on. So,
Caroline Cochran, I'm so sorry that we have to end because I feel like we could spend easily another hour interrogating you. Fascinating presentation. Thank you so much for your time.
Thank you so much. Thanks, Stephanie.